All right, let's jump right into this. Welcome to The Explainer. I'm absolutely thrilled you're here because today we're looking at something that honestly fundamentally rewrites the rules of industrial design. We spend a lot of time in the tech space talking about doing less harm, burning less fossil fuel, producing less waste, that sort of thing. But doing less harm, that isn't the same as actually healing. So today we're exploring Project Merkaba. It's a technological innovation that aims to heal the planet through these concentric, expanding impacts. We're going to see how a vehicle can be engineered to trigger massive positive ripple effects across agriculture, our energy grids, and literally global geopolitics.
Let's dive straight into the core philosophy. The guiding star of this entire project is simple. It is the first machine designed to give back more than it takes. For decades, the auto industry sustainability playbook has basically just been damage control. Even the shift to EVs, which is obviously crucial, has mostly just been changing how we consume resources rather than regenerating them. Merkaba flips that and asks a radically different question. What if the very act of building and driving an electric vehicle actively regenerated the ecosystem?
Which brings us to Section 1, the vehicle rethought. To wrap our heads around how giving back more than it takes is even physically possible, we have to strip away the standard greenwashing and look at the actual physics. The curb weight alone is staggering, just 680 kilograms. That's roughly 1,500 pounds. To put that into perspective for you, a typical modern EV weighs well over 4,000 pounds. Merkaba manages this totally astonishing lightness by using a carbon-negative hemp bioepoxy monocoque body. And this isn't just some wild conceptual sketch, it's a documented, highly engineered approach to slashing the mass we have to spend energy pushing down the highway. Basically, you shed the weight, you shed the energy requirement.
And that cascading reduction in energy and materials, it leads us to this massive data point, an 82% reduction in life cycle CO2 emissions compared to a gas-powered car. I mean, that is just an enormous leap. Most conventional EVs give you a decent CO2 drop over their lifetime, sure, but hitting an 82% reduction means you have to aggressively attack emissions not just at the tailpipe, which is zero, obviously, but deep down in the manufacturing, the battery chemistry, and the raw materials themselves.
So how is this thing actually powering itself? It uses this incredible multi-source energy harvesting matrix built right into a 13-node 10-segrity chassis. We're talking solar films, aeroboundary triboelectric harvesting, thermoelectric nodes. It's essentially soaking up ambient energy from the environment while it's moving or even just parked. And right at the heart of this energy flow is a 45 kilowatt-hour solid-state core. But the true game changer here is the chemistry. They pulled this off without using a single drop of cobalt or nickel, completely bypassing some of the most ecologically destructive supply chains on Earth. Moving on to Section 2, growing cars, healing soil. Think about this. If you're building a car body out of hemp bioepoxy, you suddenly need a massive agricultural supply chain to support it. But contrast the destructive nature of typical row crops, which absolutely wreck topsoil and demand heavy synthetic fertilizers, with hemp. Hemp is what's known as a hyperaccumulator. It literally pulls heavy metals and pesticides right out of contaminated soil through a process called phytoremediation. Imagine actually paying farmers to grow raw car materials on polluted brownfield sites, actively cleaning the earth, all while using half the water of cotton and zero pesticides. It's brilliant. But wait, it actually gets better. Hemp doesn't just clean the soil. It's an incredibly aggressive carbon sink. We're talking about sequestering roughly 1.6 tons of CO2 for every single ton of dry fiber. The Merkaba model proposes sourcing all of this within a super tight 200-kilometer local radius from the plant. So farmers aren't just selling a raw commodity anymore. They are generating verified carbon removal credits. It creates this amazing dual-revenue carbon farming stream that breathes life back into rural economies, while those deep hemp taproots physically aerate the dirt for better crop rotations. It's a complete paradigm shift. And the contrast between the raw material and the finished product is just stunning. We're talking about taking raw hemp biocomposite and translating it directly into finished automotive applications. These hemp composites are real, highly tactile materials actively replacing fossil-based plastics as we speak. They can be pressed and molded into incredibly durable, lightweight structural parts that meet all the strict auto safety standards, while basically acting as a locked vault for sequestered atmospheric carbon. All right, Section 3, a distributed energy lifeline. Cars are parked roughly 95% of the time, so treating them purely as a way to get from A to B is just a massive missed opportunity. That brings us to vehicle-to-grid, or V2G technology. V2G makes an EV a two-way street.
It draws power to charge up, sure, but it can also discharge that stored electricity back into the grid to balance sudden demand spikes, or even power a home during a blackout. Each vehicle morphs from just a ride to the grocery store into a decentralized civil defense asset.
The magic number here is the 11 kilowatt bidirectional V2G capability. Let's put that into real-world human terms. An 11 kilowatt output means that a single, fully charged Merkaba can power an average home for 2 to 4 days during a grid failure or an extreme weather event. Literally, no noisy gas generators, no panicked runs to the gas station, just a silent, totally resilient lifeline sitting right there in your driveway.
So the really crucial thing to understand is how this scales across a whole population. If you deploy just 50,000 of these units in one metro area, that combined fleet provides 2.25 gigawatt hours of distributed storage. To put that into perspective, that's effectively the equivalent of a massive natural gas peaker plant. But of course, with zero emissions, no multi-million-dollar centralized infrastructure, and completely immune to single-point failures, it offers incredible grid-level stability.
Next up, Section 4, Ethical Sourcing and Sovereignty.
It's no secret the modern energy transition is heavily tied up in concentrated mining choke points, but Merkaba offers a real way out of that trap. First off, consider the energy needed just to build the thing. Traditional lightweighting uses carbon fiber, which has to be baked in these massive autoclaves at 180 degrees Celsius. But the bioepoxy process used here, it cures at just 80 degrees. That 70% reduction in thermal energy means the manufacturing plant itself can realistically run entirely on its own on-site solar power, completely decoupling from fossil fuel grids.
Now pair that ultra-low energy manufacturing with genuinely ethical sourcing. The solid-state lithium metal battery uses 60% less lithium than a standard EV pack. And remember, it requires absolutely zero cobalt, a mineral that is notoriously tied to severe labor and ecological abuses in the Democratic Republic of Congo. Zero nickel, too, which avoids the massive deforestation we're seeing in places like Indonesia. Because hemp can grow on almost any continent, a nation can finally achieve true supply chain sovereignty. No more relying on vulnerable critical mineral choke points.
And finally, Section 5, the ultimate circular economy.
If a machine is genuinely designed to give back more than it takes, its end of life has to be just as productive as its time on the road. Instead of ending up as a rusting heap in some landfill, this vehicle enters a highly predictable 25-year reverse logistics stream. Step 1 is simple reuse. Perfectly good hub motors can be repurposed for home energy storage. Step 2 is high-value recycling, specifically realloying the aluminum and titanium. But step 3 is where the real magic happens. The hemp composite body is safely biodegraded through pyrolysis, completely transforming it into biochar.
Which brings us to this absolutely unprecedented final metric, -0.8 tons. By turning the car's composite shell into agricultural biochar, which you literally till back into the earth to boost soil fertility and water retention for centuries, the vehicle generates an end-of-life CO2 credit. It essentially becomes a permanent carbon removal device after it's done being a car, taking all that atmospheric carbon it absorbed while growing as a plant and burying it safely back into the Earth's crust. It's such a fascinating blueprint, isn't it? It challenges literally every assumption we have about industrial manufacturing. If a machine as complex as an automobile can be intentionally designed to clean polluted soils, untether our homes from fragile power grids, entirely bypass unethical mining operations, and permanently sequester carbon, well, why should we expect anything less from our smartphones, or our buildings, or our infrastructure? Thank you so much for joining me on this explainer. I really hope this leaves you seeing the massive potential of regenerative design in a whole new light.